Okay, for our next visualization, we're going to look at using a module of sklearn. We're going to use quadratic discriminant analysis to find prediction probability of today's direction. So first we're going to import the module that we're going to use. So from sklearn.discriminant analysis, import quadratic discriminant analysis. Okay, there we go. And we're just going to look at our data frame just for reference as we put columns into the train and test pools. So let's just take a look at what we would do for the training variable, x_train. We want to look at the S-market data from 2004, and we want to look at day 1 and day 2. And just to give an idea of what we're looking at, we're just going to look at the output of that. So this shows from 2001 all the way to 2004, and it shows these two columns. That's basically all that's doing. It's just taking these from the beginning all the way to the end, and then it's looking at these two columns. And that'll be our training set for our x values, and then for the y values, we are going to look at today's direction from 2001 to 2004. And we're also going to look at the output of that, just so we have an idea of what's happening. And so that's taking the year, taking this year column from 2001 all the way to 2004, and it's making a new data frame with the up and down rows. So that way we can compare the direction. And then now we're gonna work on our test set. So x_test S-market. Now we're looking at 2005 all the way until the end of the rest of the data set. And we're still looking at today's direction. We're still looking at day 1 and day 2. And we'll take a look at that as well. So 2005 all the way to until the rest of the data set, but this is the only year that it contains. And we're looking at columns in day 1 and day 2. It's basically the same as it'll be the same category of data as this one. And then we'll do our y test, and we're looking at today's direction for this one. And let's just take a look at that just to make sure we have it correct. Yes, that's correct. And so now we're going to implement our statistical learning quadratic discriminant analysis, and we're applying that to this variable. And now we're going to make our prediction variable, QDA, quadratic discriminant analysis. We're fitting this onto the training set. So our x train and our y train dot predict, and we're applying this onto the test set. Okay, fix that typo. And now we're going to create the prediction probability. So we're going to set our variable as pred_p, set that equal to quadratic discriminant analysis dot predict underscore probability, and we're going to use our test set for this. And so we're going to make a data frame out of that, and we're going to call it probability percentage equal to pd dot data frame. Our data is going to be the variable that we defined earlier. Make sure that the F is uppercase, and also let's make this uppercase too. Okay, and so since we're making a new data frame, we only have 0 and 1 here. We want to label those so we know which one is which. So we're going to name the columns. I'm going to name the first column up and the second column down. Okay, and now we're just going to chart this. We're going to make a box and whisker plot for this new data frame that we have. And since it's just one chart, we're not going to worry about the subplots. It's just one box and whisker. So SNS dot box plot data equals probability percentage. And so that's what we have so far. Again, we want to switch it because it doesn't look exactly how it is in the text. So we'll switch that again by using order. So that's better now. It looks like it's in the right order. And we also want to add some labels to this box and whisker plot. So plt.xlabel today's direction, and we'll make the font size 14. T dot, and then we'll name the y label as well. Predicted probability. The font size being 14. And so that looks pretty similar to the chart in the book. Basically, the significance of this is exploring this data using several statistical learning methods. There are some hints of weak trends in the data that suggest for at least a 5-year period, it's possible to predict the direction of movement in the market around 60% of the time. And again, this S-market data set, it's to show the significance of classification. Now we're going to move on to gene expression data.